Nomenclature of heterocyclic compounds. Why is this topic a nightmare in exams? And how can you master it easily? Most students become panic when they hear the word heterocyclic nomenclature. But what if I told you that there is a step-by-step formula that makes this topic super easy? Hi, I am Dr. Swathi. In this video, I'll show you how to easily understand nomenclature of heterocyclic compounds. Let's kill the confusion and make this topic your superpower. So what is heterocyclic chemistry? It is a branch of organic chemistry dealing with the synthesis, properties and applications of heterocyclic compounds. So what are heterocyclic compounds? As the name itself indicates, these are the cyclic compounds in which the ring is made up of heteroatoms. So the meaning of hetero is more than one kind of atoms. So the cyclic compounds in which the ring is made up of more than one type of atom, that is heteroatoms, are known as heterocyclic compounds. If you consider benzene as an example, in case of benzene, the ring is made up of only one kind of atom, that is all atoms involved in the cyclic ring formation in case of benzene are carbon. So such type of systems are known as homocyclic systems. Okay, so when it comes to heterocyclic systems, here the ring is made up of more than one type of atoms. That means other than carbon also there will be some heteroatoms present. Now what is the meaning of heteroatoms? So atoms other than carbon present in the ring are known as heteroatoms. Say for example, they can be oxygen, nitrogen, sulfur, silicon, phosphorus and so on. Among these all atoms, heterocyclic compounds containing oxygen, nitrogen and sulfur are having greater pharmaceutical importance. Now let's dive into the nomenclature of heterocyclic compounds. So the name of heterocyclic compound when it comes to IUPAC system should be written in a particular format, that is prefix followed by that root word or stem and then it should end with suffix. Now what we should indicate in the prefix, root word and suffix, let us see. So in prefix, the nature of heteroatom present in the heterocyclic compound should be indicated, while the ring size should be indicated in the stem or root word and the name of the heterocyclic compound should end with a suffix which indicates the degree of unsaturation. Okay, so whether the given heterocyclic compound is having oxygen, nitrogen, sulfur, which type of heteroatom is present, that should be indicated in the prefix. Then what is the ring size? Whether it is a 3-membered ring, 4-membered ring or 6-membered ring, that information we have to provide in the root word. Then the name should end with suffix, okay, which indicates about the degree of saturation. That means whether the given compound is an unsaturated compound or saturated compound. So that information should be provided in the suffix. Now let us see how we can write in this particular order. So when it comes to prefix, the nature of heteroatom should be indicated. So if the heteroatom is oxygen, then the name of the heterocyclic compound should start with oxa. And in case of nitrogen containing rings, it should start with aza. In case of sulfur is the heteroatom in the given heterocyclic system, then the name should start with thia. So if selenium is the heterocyclic atom, then selena. In case of tellurium, tellura. In case of phosphorus, phosphor. Arsenic, if it is present in the cyclic ring system, then arsa. If silicon is present in the ring system, sila. And if germanium containing heterocyclic ring system is there, then that should be provided in the prefix like germa. So this is how, depending on the nature of heteroatom, the prefix should be the nature of heteroatom we have to indicate in the prefix. Now that we have learned about prefix, now let us jump into the ring size. In case of 3-membered ring, then the stem or root word should contain ir, which is originated from the word tri. Tri means 3. Similarly, if the ring size is 4, that means the given compound is a 4-membered heterocyclic system, then that should be indicated as at in the root word. And if the given ring is containing 5 atoms, then it should be indicated as ol in the stem. And in case of 6-membered ring, that should be indicated as in, 7-membered ring ap, 8-membered ring oc, 9-membered ring on, and 10-membered ring ac, which is originated from deca as shown in the parenthesis. Okay, so that is how, depending on the ring size, whether it is a 3, 4, 5 or 6-membered ring, that corresponding word we have to write in the step. Now let us discuss about the suffix. So generally we have to provide the information related to the degree of unsaturation. That means whether the given heterocyclic compound is a saturated compound or unsaturated compound, that we have to indicate in its suffix. So in case of 5-membered rings, if we write all, so all corresponding to 5-membered rings. Okay, if this all OL is ending with E, means that indicates that it is a 5-membered ring which is unsaturated, like pyrrole. Okay, and similarly, if the name of the heterocyclic compound is ending with olidine, means it is like all plus idine. So again, all means it is 5-membered ring, and if it is ending with idine, means it is saturated ring. So if that all which is there in the root word corresponding to the 5-membered ring system is ending with E, means that is a unsaturated ring. And if it is ending with idine, means that is a 5-membered saturated ring system. Okay, so like in case of pyrrole, the word is ending with, the name of the heterocyclic compound is ending with all, means 5-membered unsaturated system. Okay, you can see pyrrole is the 5-membered unsaturated ring having nitrogen as the hetero atom. Now corresponding saturated compound, how we can mention pyrrole up to L. It means that it is nitrogen containing system which containing 5 atoms in the cyclic ring. Now if we want to represent the saturated system, it should end with idine. So now the corresponding saturated compound name, it becomes pyrrolidine. So this is how the degree of saturation or unsaturation we have to indicate in the suffix. So if you see the nomenclature of heterocyclic compound, it is very easy. Just we have to follow this particular format. Prefix, where we indicate the nature of heteroatom, and in case of root word, we should indicate the ring size. Just we have to see what is the, how many atoms are involved in the cyclic ring formation, and that information should be provided in the stem, and the name should end with suffix which indicates the degree of saturation or unsaturation. That's all about nomenclature. Now that we have learned about the format of writing IUPAC name for heterocyclic compounds, now let us learn how to number the heterocyclic systems and also how to name the molecules in case of substitution. Now coming to the numbering of the heterocyclic compound, always the numbering starts with heteroatom. So let us consider few examples. So here pyrrole structure is given. It is a 5-membered ring having nitrogen as heteroatom. So as per IUPAC system, we should number from the heteroatom. That means wherever the heteroatom, in this case, in the structure of pyrrole, the heteroatom is nitrogen. So we have to allot position 1 for the nitrogen. Then rest all carbon atoms or the remaining atoms should be numbered in the sequence. So this is 1 here, 2, 3, 4 and 5. So 2 to 5 are the positions of carbons, while we allot 1 for the heteroatom, that is nitrogen in case of pyrrole. Now when it comes to furan, furan is a 5-membered ring having oxygen as heteroatom. Here also we have to start numbering from the heteroatom, that is oxygen. So oxygen gets first number, then 2, 3, 4 and 5 for the rest of the carbons. Now similarly, when it comes to thiophene, it is a 5-membered unsaturated ring having sulfur as heteroatom. Sulfur will be given first numbering, then 2, 3, 4 and 5 for the rest of the carbon. So this is how numbering, when it comes to the heterocyclic compound, always numbering starts from the heteroatom. Okay, and we will follow the sequence, and the rest all ring atoms should be numbered accordingly. Now, if the given heterocyclic compound is having more than 1 heteroatoms. Now in this, again 2 conditions will be there. when the given heterocyclic compound is having more than one similar heteroatoms, and those heteroatoms can be dissimilar also sometimes. Okay, so let us now see how we can name those heterocyclic compounds. The first condition is in case of heterocyclic compounds which are containing more than one similar heteroatoms. For example, if the given heterocyclic compound is having two similar heteroatoms. Now, how usually we indicate two? We indicate that in the form of di in the prefix. The same is followed here also. So let us consider an example for that. So here two heteroatoms are there, and the nature of heteroatoms, it is similar. That means this is containing two oxygens. So that when oxygen is present, we indicate that in the prefix as oxa. Okay, but here two similar oxygens are present, so we indicate that as dioxa in the prefix. Okay, and further we have to indicate the position of the heteroatoms. So here the position of heteroatoms is 1, 4. So the same information we have to provide in the prefix. Now the name of this compound, it becomes 1, 4 dioxane. So we have to indicate 1, 4 dioxa in the prefix. Similarly, for the rest of the groups, if 3 heteroatoms present, okay, 3 similar heteroatoms are present in the given compound, then we indicate those heteroatoms starting with tri in the prefix. Let us consider few examples for that. Let us say the given heterocyclic compound is containing nitrogens, and 3 nitrogens are present in the same compound. So the nitrogen containing systems, we have to start with aza. Okay, word aza indicates nitrogen. Now here 3 nitrogens are present in this particular structure. So we can write it as triaza. Okay, triaza. Now what is the position of these 3 nitrogens? These 3 nitrogens are present continuously. That is starting from 1 to 3. That is 1, 2, 3. And 4, 5 are the position of the rest of the 2 carbons. So we can write this compound name as 1, 2, 3 triazole. So 1, 2, 3 triaza means 3 nitrogens are present at 1, 2, 3 positions. Now this ol is nothing but the stem. So ol corresponding to 5-membered ring. Now the name of the heterocyclic compound is ending with E, means that this is an unsaturated compound. You can see 2 double bonds are present in this molecule. So this is how we have to write the nature of heteroatom and how many similar or dissimilar heteroatoms are present and what is the position of those heteroatoms. So this information we have to provide in the prefix. That is what is given as 1, 2, 3 triaza. Okay, and in the stem we have written for this compound as all. That means it is a 5-membered ring, and the name is ending with E, means that is an unsaturated ring system. Similarly, another example here, this is also a 5-membered ring which is unsaturated. So you can see the stem and suffix, it becomes OLE, all. Okay, now if you see the prefix here, the position of heteroatoms, they are present at 1, 2 and 4 positions, and the nature of heteroatoms is nitrogen. 3 nitrogens are present, so we indicate that as 1, 2, 4 triaza in the prefix. So the name of this compound is 1, 2, 4 triazole. Now if the given heterocyclic compound is having more than 3, that is 4 similar atoms, for example 4 nitrogens are present in the given compound. Now let us consider in the last example, you can say it is also a 5-membered unsaturated ring where it is having 4 nitrogens. Okay, starting from 1 to 4 positions, nitrogens are occupied because we should give priority to the heteroatoms to the first. So we numbered nitrogens first, then at the end we numbered carbon position. Okay, so the position of heteroatoms is at 1, 2, 3, 4. 4 nitrogens are present, so we indicate that as tetrazole. Okay, so tetraaza, 4 nitrogens. Okay, all means stem, that is 5-membered ring system, and the name is ending with E, means this is unsaturated. So the last example structure, if you see, it is a 5-membered unsaturated ring having nitrogens at 1, 2, 3 and 4 positions. So this is how, if the given heterocyclic compound is having more than 1 heteroatoms, so we will be indicating as di. If 2 similar atoms are present, tri. if 3 similar atoms are present, and tetra if 4 similar atoms are present in the prefix along with the position at which heteroatom is present. Now, in case the given heterocyclic compound is having more than one different heteroatoms. Now, in that case, say for example, the given compound is a 5-membered ring having oxygen and nitrogen as heteroatoms. Okay, so in that case, which one we have to give priority? As I discussed already, that always we should start numbering from heteroatom. Now, if 2 heteroatoms are present, okay, so from which heteroatom we have to start the numbering. So, in that case, we have to follow a particular rule. That is, the order of citation starts with heteroatom of high group in the periodic table. Okay, that means out of 2 heteroatoms, if one heteroatom belongs to 7th group and another heteroatom belongs to 8th group. Let us consider the example of nitrogen, which belongs to 7th group, and oxygen, which belongs to 8th group. So in that case, high A group we have to consider. That means which of the heteroatom which belongs to higher group we should give priority. That means if there are 2 heteroatoms like nitrogen and oxygen in the given heterocyclic compound, oxygen should be given highest priority. That means we should start numbering from oxygen, then go to the nitrogen. This is how we have to number. Okay, so this is when the heteroatoms belongs to 2 different groups. Now, if the given heterocyclic compound is having 2 heteroatoms which belongs to the same group, for example, okay, so let us assume that the given heterocyclic compound is having 2 heteroatoms. One is oxygen, the other one is sulfur. Both these oxygen and sulfur, they belongs to 8th group only. In that case, we have to consider the heteroatom which is having lowest atomic number. So out of oxygen and sulfur, the oxygen atomic number is 8 and the sulfur atomic number is 16. So we have to consider here oxygen which is having lower atomic number when compared with sulfur. So that should be given priority and we should start numbering from oxygen. Then we'll move to sulfur and then to the carbon system. Okay, if it is present in the given heterocyclic compound. So when 2 different heteroatoms are present which belongs to different groups, then we have to see the heteroatom which belongs to higher group number. Okay, that should be given the priority. On the other hand, if 2 heteroatoms are present in the given compound which belongs to the same group, then we have to consider the heteroatom with the lower atomic number. That should be given the highest priority. So like that, if oxygen and nitrogen are present, oxygen should be given priority. Among oxygen and phosphorus, oxygen should be given priority because oxygen belongs to higher group number. And similarly, oxygen and sulfur, they belongs to the same group. Then lower atomic number should be given priority. So oxygen gets the precedence or priority over sulfur. And in case of sulfur and nitrogen also, sulfur is group 8 and nitrogen is group 7. So 8th group should be given priority. So sulfur should be indicated first. So this is how this rule is very, very important in case of when 2 different heteroatoms are present. Okay, then from which heteroatom we have to start numbering. For that we have to follow this particular rule. So if the given compound contains oxygen, sulfur and nitrogen, all the 3, then oxygen should be numbered first, then sulfur, then nitrogen. Okay, so this is how we have to give numbering in case of heterocyclic compounds containing more than one different heteroatoms. Now, most of the heterocyclic compounds, they are popular with their trivial names. Now, let us consider few examples for the heterocyclic compounds which are popular with these trivial names. So this is pyrrole. So as per the nomenclature, I mentioned previously that the nitrogen containing system should start with aza because aza means it is nitrogen. But if you look at this particular molecule, this is an unsaturated 5-membered ring having nitrogen as heteroatom. The trivial name for this is pyrrole and it is popular with this particular trivial name. And similarly, the 5-membered unsaturated ring having oxygen as heteroatom is known as furan. And the other example is 5-membered unsaturated ring having sulfur as heteroatom is known with the name thiophene. And coming to the heterocyclic compounds having 2 heteroatoms, two similar heteroatoms. If you see nitrogen containing ring system, so in this particular system, this is again 5-membered unsaturated ring having nitrogens at 1-3 positions. Okay, so we usually, as per IUPAC system, we will name it as diazole, that is 1,3 diazole. Okay, di means 2, aza means nitrogens. 2 nitrogens are present at 1-3 positions. Okay, but its trivial name is imidazole. Similarly, other example, this is also a 5-membered ring where 2 similar nitrogens are present at 1-2 positions. As per IUPAC system, we should name it as 1,2 diazole, but it is popular with the name pyrazole. Okay, and another example, pyridine. This is a 6-membered unsaturated ring having nitrogen as heteroatom. It is well known with the name pyridine. This is the structure of pyridine. So this is how some of the heterocyclic systems, they are popular with their trivial names rather than the IUPAC name. Now, in case of any substitution is present, okay, so we just learned how to name the molecule and number the heterocyclic system, because heterocyclic compounds are the compounds which are having heteroatoms, that means other than carbon also. In that case, we should give priority to the heteroatom and we should number starting from the heteroatom. Now, in case of this particular heterocyclic compounds are also having substitution, okay, then we should give priority in numbering such that the carbon bearing the substitution should get the lowest possible number along with the heteroatom. That means we have to number the heterocyclic system such that both the heteroatom and the carbon bearing the substitution both should get the lowest possible number. So that is how we have to number the cyclic ring system. Okay, so let us consider a few examples for this also. So in this example, it is a 5-membered ring containing nitrogen as heteroatom. So always we should start numbering from the heteroatom. So this is how we have to number nitrogen first and rest all the carbons. Now when we proceed with the carbon numbering, so numbering can be given like this, or on the other hand we can move on the anti-clockwise direction also. That means this carbon can be given 2, 3, 4 and 5 also. Okay, provided if it is an unsubstituted compound. But in this example, substitution is present. Okay, that is this particular carbon is bearing methyl substitution. Okay, so as per IUPAC naming, the carbon bearing the substituent should get the lowest possible number. So because of that reason, we have to give position 2 for this carbon because it is bearing the methyl substitution. So the name of this particular molecule becomes 2-methyl. So the nature of group along with the position should be always indicated in the prefix. So that information should come in the prefix. So the name of this compound, it becomes 2-methyl pyrrole. Another example, 2-nitropyrrole. Here also the ring system is same, that is 5-membered unsaturated ring having nitrogen as heteroatom. So we name that particular system, this particular system as pyrrole. Now this pyrrole is having nitro substitution at 2nd position. So that should be provided prefix. So this becomes 2-nitropyrrole. Now another example, in this example this is also pyrrole derivative only, but having 2 substitutions. Okay, so that is at both the ortho positions 2 substitutions are present. One of the substitution is halogen, that is chlorine here. The another substitution is methyl group. Okay, so in that case we have to see the priority of the groups. Okay, so halogen gets the precedence over the methyl group. So that is why the halogen bearing carbon, this carbon, we should give 2nd number, that is number 2, and then 3, 4 and 5 to the carbon bearing the methyl group. So that is how the name of this particular molecule, it becomes 2-chloro-5-methyl pyrrole. Okay, so this is how we have to name and number the carbon system or the ring system in case of heterocyclic compounds. Importance of heterocyclic compounds. So these heterocyclic systems are present in some of the vitamins such as vitamin B1, which is also known as thiamine. You can see here this is pyrimidine ring and here it is thiazole ring system. So this vitamin is useful to keep the nervous system healthy, and it strengthens immune system and also improves blood sugar management. And then vitamin B2, which is also known as riboflavin, also containing the heterocyclic systems. And the other vitamin B3, which is also known as niacin, is containing pyridine ring system, which helps for enzymes to work properly and helps skin, nerves, and the digestive tract stay healthy. So these are a few examples for vitamins which are containing heterocyclic rings in their structure. Similarly, a few examples for antibiotics. So antibiotics such as penicillin, cephalosporin, they contain heterocyclic ring system. So you can see in case of penicillin, it consists of beta-lactam ring which is fused with thiazolidine ring system, and this is again in case of cephalosporin also it contains beta-lactam ring which is fused with 6-member heterocyclic ring system. So like this, some of the antibiotics also contain heterocyclic ring system in their structure. Similarly, natural and biological products such as hemoglobin and also chlorophyll, okay, they contain heterocyclic system. So you can see both of these structures, they basically consist of pyrrole ring system. Okay, so these 4 pyrrole rings are fused in a network form, and this particular core ring system is known as porphyrin ring system. So this porphyrin ring system is complexed with iron in case of hemoglobin, and this porphyrin ring system consists of magnesium metal in its core in case of chlorophyll. So that is how several vitamins, antibiotics such as penicillin, cephalosporins, and natural products such as hemoglobin and chlorophyll are having heterocyclic rings in their structure. Now that you have learned about the nomenclature and the importance of heterocyclic compounds, now it is your turn. Note down these structures and write the nomenclature of these 5 compounds with numbering. So if you have completed this task, give your answers in the comment section. And if you want more bite-sized organic chemistry lessons, hit the subscribe button and stay tuned for my next coming videos. Thanks for watching. I'll meet you in my next video.